evaluating limits from tables. So we have a function here of g of x, and we see here that as x is approaching 5, as x equals 5, g of x returns a value of 6.37. But the question is going to ask us, as the limit is, what is a plausible value that g of x is approaching as x is equal to 5, or as x is approaching 5. And we see here that, 5 is defined, we can just use direct substitution. And that might be the case for some answers here, or for some limit evaluations. But we also remember that there are jump discontinuities, or there are removable discontinuities. And simply put, a removable discontinuity is if you have like a graph here. It's like, let's assume this is a linear line. And then here, there's a hole because the point is not defined there. And then let's say the function is another function. The point is defined here at a higher value. So although this value, let's just assume this is 3, 2, 1, 6. And let's assume this function is f of x. We might assume f of 3 is equal to the height of this point, which we'll just set relative to 6 or something. We'll assume f of 3 is equal to 6. And then we'll say, we might assume then that the limit as x approaches 3 is 6. But we see here that the left and the right hand side are approaching a different value, this value right here, which is x. And that's the issue here. We can't always assume that the point plugged in to the function is going to return as the limit value. So it's unfair to assume that x, as the limit as x approaches 5 of g of x is going to be equal to 6.37. So we use a different approach here, and what we're going to do is we're going to look at what the left and the right hand side approach, because ultimately those are the only things that decide the limits. So from the left hand side, we see that g of x is getting bigger. So let's draw that out. Actually, we can't really draw that out because it's too small. But all we know is that from the left hand side, x is getting bigger. But we see here, or g of x is getting bigger. We see here that there's not much change between 99 and 0.999 and 0.99999. And the change is going to become increasingly smaller because there's going to be smaller changes in x, because 0.09 and then there's 0.0. There's a change here from 0.09, and then here there's a change of 0.00. And the issue here is that the change is just going to get smaller and smaller as x is approaching 5 from the left hand side. So we can also assume that the change in g of x is also going to get smaller and smaller. So we see here that 3.68 is probably going to be extremely close to the actual value that the function is reaching. And from the right-hand side, we see it's decreasing to 3.68. And if we say that the function, or the limit as x approaches 5 of g of x is 6.37, it's going to be unfair to here, because no matter how close we get to 5, if we do 5.00000001, it's probably going to be somewhere around the 3.7 mark. So here you have to realize that 6.37 is probably going to be a removable discontinuity, because as the x is getting really, really close to 5, from either side it's approaching 3.68 or 3.69 or even 3.7 as opposed to 6.37. And therefore the limit is going to be 3.7. So always make sure that you're evaluating the left-hand side and the right-hand side to see what they're getting increasingly close to, as the x is getting increasingly close to the limit value.